Today we will be multiplying and dividing decimals. Let's look at an example and then generalize what we do when we multiply decimals. If I take 3.2 times 0.25, I do not line up the decimals, I line up the numbers. So I'm going to multiply. 5 times 2 is 10, 5 times 3 is 15, plus the 1 is 16. Place it down. Put a placeholder, an X or a 0. 2 times 2 is 4. 2 times 3 is 6. I add together 0, 10, 8. Then I count how many decimals are actually in, or how many numbers are behind my decimal in the problem. I have 1 here, 1 here, and 1 here. So I have a total of 1, 2, 3 numbers behind the decimal in the problem, which means I'm going to have a total of 1, 2, 3 numbers behind the decimal in my answer. So my answer is 0.800, which I can also write as 0.8. So to classify or to generalize multiplying decimals, 1, I'm going to line up the numbers, not the decimals. 2, I'm going to multiply like normal. 3, I'm going to count how many decimal places or how many numbers are behind the decimal in the problem. And then 4, I'm going to put that many numbers behind the decimal in the answer. You're going to create way more work for yourself if you line up the decimals when you multiply. There's absolutely no reason for that. So let's take a look at another one. Let's look at 42.6 times 0.72. Again, I lined up my numbers, notice, not my decimals. Then I'm going to, step 2, multiply like normal. 6 times 2 is 12, 2 times 2, 4, plus the 1, 5, 2 times 4, 8, placeholder or 0, 7 times 6 is 42, 7 times 2 is 14, plus the 4 is 18, 7 times 4 is 28, plus the 1 is 29. Add them together. Then I count how many decimals are in the problem. There's 1, 2, 3 numbers behind the decimal in the problem. So I'm going to have 1, 2, 3 numbers behind the decimal in my answer. So my final answer is going to be 30.672. I need to then check for reasonableness. So if I'm working a word problem, for instance, this first one, let's assume there was a word problem involved in it. 0.25. That's like 1/4. So if the decimal that I'm multiplying by is smaller than 1, then the number is going to decrease. It's going to be cut smaller. Here, again, I was taking 42.6 and I was multiplying it by 0.72. 0.72 is a number that is smaller than 1, so therefore my answer is going to be smaller than the original. Let's take a look at one where it's bigger. Let's look at 6.7 times 9.8. Again, the order, I did not line, well, this time I did line up the decimals just because it happened that way, but I lined up my numbers. 7 times 8 is 56. 6 times 8 is 48, plus 5 is 53. Placeholder, X or 0. 9 times 7 is 63. 9 times 6 is 54, plus the 6 is 60. Add them together. And then I have 2 numbers behind the decimal in the problem, so I'm going to have 2 numbers behind the decimal in the answer. So I have 65.66. If I notice, both numbers are above 1, so I knew that my answer was going to be larger than I started with. Let's take a look at dividing decimals. Let's take a look at 7 divided by 3. 0.7 divided by 3. That means 0.7 is going to go inside my division. 0.7 divided by 3. So now, since I have no decimals on the outside, I'm just going to move my decimal straight up and divide. 3 goes into 7 2 times. That's 6. Subtract. My leftover is 1. 3 doesn't go into 1, so I bring down a 0. 3 into 10, 3 times. 3 times 3 is 9. Subtract, and I get 1. The 1 that I keep getting is a repeating. Let's check and see what happens. Bring down a 0. 3 into 0 goes 3 times. So what part is repeating? This 3 part is the repeating part. It's the part that continues. The 2 happened only one time, but the 3 is going to keep happening if I keep putting it up there. So the 3 is the repeater. Let's take a look at 2.4 divided by 0.3. Again, 2.4 goes inside the box, and I'm dividing by 0.3. I cannot have a decimal on the outside when I'm dividing, so I need to make it disappear. In order to do that, I'm going to move it behind the 3. That way it's 3 wholes. What I do to the outside, I must do to the inside. So this decimal will move over here, so it'll become 24 wholes, and I move the decimal straight up. 3 doesn't go into 2, but 3 goes into 24 8 times. So my final answer is 8. If I'm taking a number and dividing by a number smaller than 1, then my answer is going to be larger, because technically I'm taking 2.4 and dividing it into a little less than thirds. Let's take a look at one more example. Let's take a look at 342.6 divided by 7. When we're looking at a fraction like this, we can say 342.6 over 7. We can also say 342.6 divided by 7, because this bar means divide. When I'm taking this and going to divide it, the top goes in the box, meaning the division house. The top goes in the box, the top goes in the box, dun 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 dun, dun. The top goes in the box. So I'm going to put 342.6 inside my box and 7 on the outside. 7 does not have a decimal, so we're good. Bring this decimal straight up and divide. 7 into 34 goes 4 times, and that's 28. 6 remaining. 7 goes into 62 8 times, and that's 56. With 6 remaining. Bring down the 6 like normal. 7 goes into 66 9 times. With 3, that's 63, so I have 3 left over. I can add a 0 to keep going. 7 goes into 30 4 times. That's 28. 2 left over. Add a 0. 7 goes into 20 2 times, and that's 14. 6 left over. For the most part, we will say in our problem to stop after you get to a certain part. So for instance, if I said round to the nearest tenth, the tenth is 1 place behind the decimal. So my answer would be 48.9. If I'm dividing by a number larger than 1, then my original number is going to get smaller when I get my answer.